to show you for loops.
Mm-hmm.
All right, so in almost like any programming language, I'd say you need to know like two things at the end of the day. One of them is for loops, which allow you to do things iteratively over things,
Mm-hmm.
and if statements. So if this, then that. Right? Those are like the basic building blocks of like any function, anything something does. Like for example, subsetting is really just logical if statements, and then doing things over multiple columns is a series of for loops. I mean, granted, like you don't write everything in for loops and if statements. There are other functions that do things better, but excuse me, at the end of the day, that is kind of what everything boils down to.
Okay.
So I want to show you for loops because sometimes it's more intuitive to
Mm-hmm.
do that. So let's say these are day calls, and I'm making a variable called day columns, and these are the columns that have dates in them, for example. And we're going to do the base data set. So right, we have this day. So column names, right? I want to grab these out. Dput. Dput is not a really useful function for like analysis, but like for example, right? I wanted the column names, right? But I wanted R to make them in a way that actually wrote R code out for me that I can copy and paste, for example. So dput allows you to do that, but again, not very useful in the day-to-day stuff. So anyway, I want to take, so these are all the columns that I want to do stuff over.
Mm-hmm.
Okay? So, okay. So here's the syntax. For, right? And it'll turn up blue because it's kind of like a special word in R. Parentheses, right? You always have to have parentheses around the statement. And then you make some indexer, right? Something I'm going to call later. And then you say in, right? In is also blue because it's a special word. And then you put a vector. So what this is saying is go through every single element of day calls, right? And store that in this thing called iCol. So I'll show print head base iCol, right? Okay, so this is another important reason why the other kind of subsetting is important. Because if I say like base $iCol, it'll say, I don't know, there's no column that's named iCol. But when this will make more sense when I just call this. So I'm going to run this. So every single iteration, right, it goes iCol equals this variable, or sorry, this string.
Okay.
Then in the next iteration of the loop, right, it goes all the way to the bottom, stops, and then it goes back to the top, reruns the code, but now iCol has changed to this day, for example. Right?
Okay.
So it's just iterating over, it's doing the same thing, just changing, swapping out this specific variable that I set. There's nothing special about iCol. I name it iCol because whenever I do a for loop, usually whatever I'm indexing over, I usually start it with I something.
Mm-hmm.
You'll see if you read online, for example, like this might be an example of a for loop, right? So for I, so just some indexer in 1 to 5.
Okay.
And then what this will do is it'll print out 1, print out 2, print out 3, oops, I. Okay, you want to take them?
Oh, yes.
Okay. So for each, but I as an indexer, I think is not very informative, right? I don't know what I'm indexing it over, but it is short, just saying I. So a lot of times, if you do look up anything for a for loop online, it'll have I as an indexer. But I'm going over each column, so I call it I column. So now, for example, let me just. I'm just putting it. Whoa. I'm just printing. All this is doing is printing out an empty space, so you can actually see the separation between the printing. So what this is doing, it's now saying the base data set, right, which has all the baseline data, and it's subsetting with iCol. But iCol is now a character, it's a string, and so when it does the subsetting, it grabs one of these names and pulls the correct column off of base.
Okay.
Okay?
Okay.
Does that?
those are only from the first, right?
So we're gonna do it separately for
Okay.
each because one, they're not all named necessarily the same thing, and not only that, not every. So for example, daily doesn't have these variables, and base doesn't have columns for dates that base has. Right. So I'm just gonna do them separately because it might just be a little bit
Okay.
easier to do
Yeah.
that. Okay. So what are we gonna do? So whoa, not that. I'm gonna take all this out. So I loaded this other package called lubridate. I guess it's supposed to be like lubricate, but for dates to make it easier. This is another package from the RStudio team that's very good, and it's great with dates. So all you have to do is kind of tell it, okay, this function here, because I know this goes in month, day, year, right? That's what this function is here. If for example the format of the date was day month year, right? There's a function for that. There's a YMD function, and there's also these other ones, YMD underscore H underscore HM underscore HMS, right? For hours, minutes, seconds. So if your date, for example, was 1/16/2011 002300, right? And you said DMY, or sorry, it's MDY, right? For month, day, year. It'll say, I don't know what you're doing, but if I say hour, minute, seconds, it converts it to a date. So you'll note though that this it's kind of confusing what they call it, but it's just a date format. That's what POSIX CT and POSIX T is.
And then when we use that, then we can calculate, for example, how many days when you want
Exactly.
to subtract.
Yeah, so you can just subtract dates normally, like the way, like normally subtracting, like you would just subtract numbers, for example. Okay, so I'm gonna run this. 3 failed to parse. Okay, so it's telling me that 3 dates weren't parsed correctly, or they weren't parsed at all. They were unparsable, and that could be spacing. That could be a lot of things. So what I'm going to do is I'm actually going to read the data back in, and we're going to do this one more time, but I'm going to make a new column with the dates, so that then I can cross-reference which dates are NAs and look at the original data to say what kind of went on with that. Okay? So what I'm going to do, new col is, so I'm going to paste together iCol, which is, again, these things up here looped over, and I'm going to say date, right? So for example, before I run this, let's run this. So now that is the column name that I want to make a new one out of, right? So now if I do this, it's not going to replace that column. It's going to make a new column, okay? Okay, so let's see. So what I want to do now is I want to filter the data set base, and I'm going to say is.na, for example, and I'm just going to do this. Doesn't want to copy for some reason. So none of those are missing, right? None of those are. So when it fails to parse, it makes them NAs. Oh, sorry. This is the variable we really want. Okay. So you should note that these dates are a little bit different, right? They are not the 1/2/3/, right? So if I say that, if I say head base, for example, this is the format that's right. So this is not an uncommon problem, sadly, in data, that dates sometimes come in all shapes and sizes and formats. And that's not great sometimes. So what are we going to do? What we can do is we can select these rows. There's a lot of different ways we can approach this problem. What I'm going to probably do is say, are you missing? I'm going to take these dates here, and I'm just going to add it's because it doesn't have a 4-digit year. I'm pretty sure that's why it doesn't parse, and it's also not consistent with the rest of them. So let's look. I don't remember if it likes so anyway, I don't. If I have a solution to it, let's just do it. I don't care. Like if there's like the correct way or the way they recommend, I'll do it the way I think. So okay, we got this. We got this new thing. So now we got base. Right. So we're looking at this guy, right? And some of them are NAs. So we want to say, let's say bad strings is these oops. So what am I doing here? I'm saying I'm taking the original variable, I'm subsetting that original variable by the ones that were converted incorrectly. They're NAs. Okay, does that make sense?
Yeah.
Okay, so now bad strings are these things. So there's a function that I really like called string split, str split, bad strings, and I want to split it on the hyphen. Note that if you're using this, by default, it uses these things called regular expressions to split things. So that just means if you're splitting on something and you want to be very sure that when it matches, it really means that specific thing, just say fixed equals true. And the idea is that like in these regular expression things, there are certain characters that mean certain different things. So the period, for example, will match any single character in a string. So you don't, if you want to split on periods, for example, and you say, so if I say str split bad strings period, you would think it shouldn't split anything, and actually it splits everything. It treats every single thing as a splitter. But if I wanted to actually split on here, let's just okay, don't worry what that did. Let's just say this was our example, right? We would just say str split bd2 period, and then we'd say fixed equals true. Okay? So the fixed means whatever thing you're splitting on, I really mean it has to be this, right? So there are some other special characters, like the question mark is special, the $sign is special, periods are special, the asterisk is special. So just be aware that if you're trying to split strings with str split, put fixed equals true, and it should work the way you think it should. Okay, so we split a string, right? So here's where we're getting to the some of the complicated objects in R. So this is what's called a list. Okay, lists are general containers of things. They're different in two aspects, really. They don't have rows and columns or anything like that, and their referencing is a little bit different. And that I mean like subsetting. So for example, if I take SS1, right, the way we normally subset vectors, it'll give me this thing back. But if I say class of this, it'll give me the first element. That is what it will actually return is not the thing inside of it. It'll return a list that contains that thing. So the way I like some really bad analogies for things. So I'll try to make this one better. I enjoy this one. I don't know if it's good though. So I think of a list as like a refrigerator, right? So a list can contain, a refrigerator, for example, can contain just like raw food in there, right? So just vegetables hanging out. So in that sense, a list can contain example, just vectors, right? So each one of these, each element of this list is actually a vector. It could be a matrix, it could be a data frame, it could be anything, okay? But like in a refrigerator, you also have like Tupperware, for example, right? Tupperware, which contains some food. So if the food is a vector, right, and the Tupperware is another container like the fridge, so in that sense you can have lists within a list. Does that make sense?
Yeah.
So it's like a general container, and you think about your fridge, it's a list. You can put anything in there that you want. And you know, like those, like the Russian dolls, it could be a list and a list and a list and a list, and that's okay. You just have to know kind of what the elements are that are inside your list. So if you want to extract the first element, you just have to put these double brackets around it. So what that will give you is the vector, is the thing inside of it, is the food. It'll give you the food back rather than a Tupperware container with the food. Okay?
Yeah.
So, lists, explain with food, right? So now, there are ways that, so we're not going to do, so there are another class of functions, and they're called apply functions. And not surprisingly, they apply a function to a list, or to anything really. And so, they're like for loops in the sense they will loop over every single object in that list and do something to it that you want, but it's a little bit more compact than a for loop. What we could do, right? So for I string in seek length ss. So what this is going to do, seek will just say, give me a sequence, right? And this will do 1, 2, 3. It'll give me a sequence for how long the list is, right? So the list is like 3 elements. There were only 3 bad strings, right? And I want to just say, give me the index 1, 2, 3. But the reason I didn't do just like 1 to 3 is this is a little bit more dynamic in the sense if SS in your new data set happen to be like 4, it's not going to be bound by the 3. So what we could do is we could say like SS I string, right? Let me show you when I string equals 1, right? That'll bring out the 1 that we want, right? So let's say X is that, okay? X3, oops, is the year. We know that's going to be the year for this specific format. So we actually want to just paste 2, 0 in front of it, right? 2013. Now what we can do is SS I string equals X, 3 equals X. So what this will do, this is pick off element I string, put 20 for the year, put 4-digit year back. Okay? Now, we got strings. Great. Now what do we want to do? We want to now go over all of them. Actually, no. Let's step back. This will probably be easier. Right? Well, if we rerun it, it'll keep pasting 20 on there as many times. So you have to rerun this string split thing. Okay. Sorry. Okay, so X is 2013. Great. This is actually the way we're going to do it. So, okay, pick off an element of the string, right? So X is these 3. It's a character vector of length 3. For the third one, which we know is going to be the year, I want you to paste 20 to that. Okay? So now X is the way we want it. Okay? Now, I want to join that back together, right? And let's say with hyphens again. That's okay. So what we'd say is x equals paste 0, x collapse equals that. So that'll take a string, that'll take a vector of characters or vector of numbers. Collapse will join it all together by whatever you say you want to collapse them together with. Okay? Oops. So now we got a 4-digit year. Now we're going to put that back into this thing. Oops. We're going to take this out, right? Because we're going to replace that entire element with this one thing now. Okay? Now they're all like that. And when you want to take, so these are all, this is a one big list with each element just being a string now. When we want to convert this back to a vector, right, you unlist it, right? So okay, now what do we want to do? We want to, now watch, if I say, what is that? That is day, month, year. Great, right? So what we want to do is we want to now take these entries, we want to take this, the ones that are NAs, and we want to replace them with this. Okay, so this is a little complex statement again, but it's saying grab this column, find the ones that are NAs, right, which is what we did up here, and now put them to the new and improved, awesome date. Okay? So now we can say, are any of them NAs? No. So date fixed for that, for that one specific column. Okay? Now there are faster ways to do that. And actually, I'm not even convinced that you needed to do the 4-digit year. So I wonder, for example, if I took bad strings. Oops. So now it doesn't grab anything because there's no longer NAs. So I'm going to rerun everything just to get it back to kind of where we were. So bad strings. I wonder, you might just be able to say month or day, month, year, and you could have just done that on there. I wanted to show you the for loop. I wanted to show you lists. So I will comment all this stuff out because it's important, but there's a much easier way to do it. We can just say this equals day, month, year, bad strings. Okay? Then we can say any. No. And we actually knew that off the bat already because we didn't get a warning. Because if any of those, even the ones that didn't work the first time, if they didn't work the second time, it would still have warned us and said, hey, like, you still got some stuff going on wrong. So now, what we're going to do is run that same idea. And the reason I'm not going to loop over this, the reason I'm not going to loop over the columns and just make this code do it for every single one of them is because I'm not, again, I don't trust anybody or anything, so I'm not sure that those other columns, that their dates are in the wrong, not wrong, but in the same different way, right? There's like the one quote where it's like, you know, I think it's about like families. Every like happy family is like exactly the same, but like every unhappy family is unhappy in its own way, or something like that. So that's what I think of every column, right? That it could be totally different. So let's see. Oops. Right? These also are going the same way. So
You can do the same.
yeah. So you can loop through them, right? What we can do is print. Okay. Okay. Now, if you think it's not going to be many, right? In this case, we only saw about 3. What this will do, this will print out, right? This is just grabbing. So bad rows is.na. Okay? Bad rows. And so print out those specific elements that are bad, right? Okay. So now we see a couple things. So for this one, pretty much it's fine. For this one, they're all like different in the same way. This one, same thing. Now for this one, it's a little bit different. There are NAs. There are empty dates, right? So what I want to do, probably before I start parsing, is I want to probably change the quote, the empty quotes into missing, right? Because they truly are missing, and I don't need to see those, for example. They're not there. You might want to check later if, for example, this variable, it doesn't make sense for that to be missing, then you want to check that out, right? But let's say, so missing date, okay? Okay, so this will replace. Does that make sense?
Yeah.
All right. So now we're replacing this kind of stuff, and now we're putting in, put in date format. Okay. So the nice thing about this, now we know. Okay. Every time something does go wrong, it happens to be the fact that it's a 4-year problem, right? Or actually, it's just a different date format, but we know that format is DMY. So what we're gonna do is now we're gonna take this guy in there. So we're gonna say bad strings, and we're gonna take out these, and then
we will do
all the ones we're looping over. Okay, so now it'll say these are the bad strings. Bad strings. Is it missing? So missing date. Again, we're gonna make that. Okay, and we're gonna say. So what we're doing is saying find the dates that were parsed wrong. Okay. Actually, we don't even have to do that. We already have that. We made bad rows that. So we already know. So bad rows. Oops. I didn't want to take out that. So we got bad strings for the bad rows. We're going to take the original column off, right? Because now they're NAs. Now they're NAs in the date column, right? So we want to take the original data, and we want to say base bad rows new column is now change it to the date. Okay. Now we're going to get 2 sets of warnings. It said 3 failed to parse, and that's a nice thing. That's the nice thing about this function, because it tells you how many failed. So if it was like 100 or like anything above like 20, you probably don't want to have it printed out every time. You probably can't. You might not be able to assume it's the same. So you might want to have to inspect it a little bit more. But here it tells us 3, and then now we can see, like, other than this one, there should be no NAs in this variable, right? So we can say like any is .na the base, right? Right. So there's no. So any just takes a logical and say, are there any trues in there? All is the opposite in the sense they all have to be true, right? So any and all. They're just little logical, I wouldn't say tricks, but they're just little logical operators.
One question, when you put a semicolon on the top on the column is what, in the 54, row,
Yes.
you start a
Oh, yeah. So this is actually a curly brace, right? So it should be above the next to the P, I think, on your computer. So that I forgot that's a good question. So for loops and if statements have to be in an expression or in these curly braces,
Oh, I
right?
see.
So
Okay.
that's the big thing that
And all need to finish with a.
exactly it has to finish with that. So it says everything in here. I want to run that code every single time, just replacing this new thing out.
And I can use that for any other code that I want
Yeah,
to
I mean, it
write.
can be a new column or something like that. That if you want to try to convert dates, yeah, this should convert.
It's kind of like I group all my codes to run every time.
Yeah. So there. Are you trying to say like can we make is there can we make this into a function so it's kind of more general?
Yeah.
Is that what we're saying? Yeah, there is a way. There are ways to do that. So we can talk about that. That's a little bit more. And that's not super advanced actually. What I'll say is here. Let's save this. And R Studio has this nice thing which tries to like extract a function. No. Oop. So I think you can, if you try this, I think you can say like extract function, like make date. So, what you can do is, so this is the syntax for making a function, right? So it's just normal like assignment, right? So you say this equals something. You can also say equals here. By default, they do the little arrow. You say it's a function. You say what the inputs are to that function, and then you put the curly braces around it. Okay?
Yeah.
So this is the name of the function. These are the inputs. And what R will assume is the very, very last line is what you want to return to the person, right? The output. There's also, if you want to be explicit, you can say return whatever you want to output. So this is a good exercise, I think, right? So make date, and X will be one of the vectors, like the vector of dates. Okay, so now we got, so we don't need to paste stuff together anymore, right? So we just want the data, right? So it's just data, right? So it'd be X, X, right? So now it's saying missing date is X in quote quote for all those. So here, okay, any. Okay, now kind of as a nice segue into if statements. So we say missing date. If any are missing the date, right? So again, this percent in percent will give you a logical yes or no if it's in this, and any will say, are any of them missing? If so, then execute this code. Okay, so this is just so again, and you can have like compounds like if this and this or this or this, right? So any kind of logical operation that you normally would use in R anyway. Okay, now I'm going to call this X date. Okay, so I'm saying X date is now the month, day, year of X. So now the bad rows change to X date, right? And then we can print X bad rows. Okay, so we'll just print out the bad ones. Then, for example, you can add another argument with a comma. So, and you can define a default, right? So this, for example, I'm saying verbose And then because I already know it's going to be logical, it's got to be illogical the way it's inputted. Then it says, if you want me to print like diagnostic stuff. So for example, do you want me to print out the statements that were bad? Right? For example, here, that will only happen if verbose is true. So if I run this function and I set verbose to be false, it won't print them out. Right? Like in the case where you have like 100.
Yeah.
Okay, now what this will do is we want to grab, we have bad rows. We want to grab X and the bad rows out. And then we want to say X date. Those bad rows are now that. We want to return X date. Okay? So let's copy this guy into the new function. I'm going to shrink this down a little bit. So usually, I'd say the standard practice is if you're going to define a function or load in any packages, to do it at the top. So it's always, my scripts always start out with usually clearing the workspace. So something that I was working on before isn't left over. Loading in my packages, loading it, sometimes setting the working directory, and then defining whatever functions I want to use. If they're new, right? Yeah. Okay, so now what we can do, again, so there's going to be so I do not recommend this of having like a whole bunch of commented code out in your file, but I'm going to leave this here just, again, for illustrative purposes. So, whoa, don't want to do that. Now, we can say base new col, right, equals make date base icol. So that will replace everything. Right, let's just comment all these out. We don't need these anymore. Right. So now we have a nice, so yeah, there is always this trade-off between the code being very explicit, so easy to read, versus it being kind of what I would consider elegant in the shortest possible form possible that you could use. Okay, now it ran. Now we can still see we should still be able to see the same. The output, the function should have done the same exact things we were doing before. Okay, so now we got dates. Great.
I have a question. For example, if before you do all of this and you create a new function, a new variable based on the original date, if I didn't do that, R will assume that those are kind of like missing or MA.
Sorry, what do you mean by that?
For example, the 4 that was in different formats, if I try to make a new variable, what R is going to do with this 4?
If when you make the new variable and try to set it as a date, it'll put them as NA. So although there was an original string that was this different format, the warning pretty much said, I don't know what those are. They're not like the rest of them. I'm gonna just make them missing.
So that's good. It's better first check that everything is in the same format and then create new variables.
Yeah, I guess that is one layer of trust I kind of will go with, that like things, if they are in the same format, and things don't warn me that they failed to parse, that they parsed okay. Now, there are some instances where like you just are kind of sunk in, like if you have European versus US type dates, you just don't know. Like is 5/6 June?
Yeah, you didn't know if it's
May. Like that's kind of a data quality issue. That's kind of before you maybe even load the data in. But for the most part, if it tells you it doesn't warn you that it didn't parse, then you're probably okay. Right? So there is one other. So again, I'm telling you like all these packages and all this kind of stuff. Actually, we don't even need this. I'm going to put one other function in here. Into this, one other step. And that is, I don't know if the lubridate functions will do this by default, but I like to just be explicit. So we're going to say x equals trim ws x, which equals both. And that means I want to trim the white space. So if it's like date plus a space, or a couple spaces, or it's a space, then a date, right? I will just take that white space away. Okay?
Yeah.
Just to make sure that, I don't know. So I will tell you, in almost any system, dates are sometimes one of the hardest to deal with, right? Now, we'll do one of these apply type statements, and I'll show you how to do things on like a person level.
Okay.
Well, so now we got base kind of going along, right? Let's look at the daily data real quick. I'm gonna move this guy over a little bit. So now you're actually like getting into the thick of it, of like real data. So now we got this. So daily data. So let's make daily date equals. We're gonna paste. So again, I'm using paste, not paste 0, because I want a space in between things. So I'm gonna say daily. Let me use the commands I showed you before. Mutate. And I want to say daily. I want to make a new column that's called date equals paste. And it's the daily day and the daily hour. And as I'm saying this, I'm realizing we should probably check the formats of the daily dates. So let's just see. So daily equals mutate daily date. I'll just call it like dated or something like that. And we think it's month, day, year, and it'll give you everything seemed to work well. Any is .na, daily, dated, false. Okay? Good sign. All right. But what we're going to do here is, so actually, I'm just going to call that date, because I'm actually going to overwrite it right after that. Why am I going to do that? Because I want this in a date time format. Right? I don't just want it the day, I want it the whole shebang, dates and times. So I should be able to do the same thing. Right? I could do all this in one statement, but I'm not. And I want to say month, day, year, hour, minute, date. Okay. 60 failed to parse. Not a good sign. But not that bad. Right? So let's look at the head daily is.na daily date. Okay? So what happened? We got some different formats. Well, no, we don't. That's not. No, we have no times. We have no times actually. No daily hours.
Oh, that's why.
So let's make a compound statement. Okay, so I'm gonna again make this a little bit bigger so you can see it. So we're saying, show me the ones where the date is missing, but the hour is not missing. That's what this little not is telling me here. And there's none. So turns out all of them that are missing when you try to parse it on the hour and the minute actually are just because of the time is missing. Now, this is good to know, but so it tells me maybe we should just use the day. right? Because that's what you were doing anyway.
Mhm.
So let's just take the rest of this out, and then date is now just that. Okay, great. Now I want to arrange the data, and I want to arrange. First, I'm going to do ID. Oops, go in here. Okay. I want to arrange by that, and then I want to arrange by the day, right? By dated. Oh, that shouldn't be dated. Daily. Remember, daily dated. Null. We'll get rid of it. And I don't have to put that in the code because I took that stuff out. And so when I rerun it, it won't ever know dated exists. And I want to say date. So I want to arrange. Here is a. So let me just see one thing. Yeah, okay. So what went wrong? What went wrong is that when it was trying to order these, hold on, let's see. It looked for, oh, sorry. No, it's because I didn't do it right. There. I didn't put the right data set in there. Okay. 90% of the time is user error, right? It's me, right? Okay, so I always sort ID first, right? Because if we didn't sort that, it would just sort the dates all willy-nilly kind of anywhere. And now we're going to do one of the apply. They're called apply statements. So the syntax for this is dplyr. And these apply statements can do a whole slew of things. And they have a whole suite of them that depends on what your input is and what your output is. So dplyr stands for D, the first D is I'm inputting a data frame. The second D stands for I want a data frame out. Okay? So if I say like dplyr, that means put a data frame in there, apply a function, and then give me a list. That's what the L stands for. llapply, put in a list, you get out a list. Like lapply, put in a list, you can get out an array or a vector or matrix. Anyway, dplyr, probably one of the most useful, especially for standard data analysis. But the syntax is a little weird, I will give you that. But what it can do is will do operations based on splitting something else. So in this case, what do I want to do? I want to make a variable, for example, and split by the ID. So now that they're sorted, I want to take the data frame and I want to do one thing on this person's data, one thing on this person's data, the same thing over and over again. But now you can do things on a person level, right? So now, if you didn't, let's say you didn't have this day n,
Yeah.
right? So, and actually it was really good that you asked about functions, because this might get a little confusing. X day n2 equals x date minus x date 1 x. Now, what this is doing is saying I want to take this data frame daily. I want to split it. Let me move this over. I want to split it by ID, and then you can either do a few things. You can either give it a function, something that's already defined, right? Or what you can do, like I'm doing here, is define a function on the fly. So do it just for that. Like I don't want to save this, right? That's not like a super useful function to have. But what I'm doing here is I'm defining a function. The input, I'm just calling it x. The input is the data frame that's split up, right? So what will come into this function is, for example, all the data from ID this person first. and then all the input from the next person, and then the next person. And so what we're going to do is now we can say we know that the first one is the first day because we just sorted it. Now we can say give me this and subtract out that. So let's do a quick example of what I'm talking about. So let's do x equals daily ID is this guy. Oops. Right? So x, right? This is this person's data. They got a lot of data, a lot of days. So now, oops, we made day n, or sorry, you made day n. I said I made day n too. Now by default, when you subtract off dates, it gives it to you in seconds. That's not really what we want. Wait, what is y day? So hold on, diff time, I think. So I think you can say what you would just say: units x day n2 equals days. So now it tells you how many days. It's by default in seconds. The other way we could have done it is diff time. Right? It takes a difference in time. And it takes time 1 minus time 2. So time 1 is these dates. Right? Time 2 is actually the first date. And we can say units equals days. Okay?
Yeah.
So that'll give us it back. Right? We could have said as.numeric on the thing and multiply it or divide it by like 86, whatever, how many seconds there are in a day. So now, the nice thing about this is if you have a very large data set, for example, you can say dot progress, and I like text progress bar. So it tells you how it's going along. So like, for example, if the data set was like really big, and you just want to see like how long is it going to take approximately, do I have time to get some coffee, like this will give you an idea. Okay, so now this case hasn't been very helpful because you've already defined that variable, but now you can see how you can do it's simple to do ID.
But also help me to check if my day n is really true, because that was maybe you received that data, but you didn't know.
Again, don't trust anybody.
Yeah.
So we can do that. We can say like, do all of them equal? The answer is no. Now we can see why. So, so daily with the rows. Whoa. So, what's going on here? So, I don't know. This says it's the 6th day for this person. This says it's 8 days out. So let's look at it. So let's do x is daily ID is this. Okay. So so what I actually don't want to see that. I want to see the day n. I want to see the day n2. Here, let's use the dplyr.
Yeah.
So x, what is it? It's not subset. It's select. That's it. X, and I want day n2, daily date. Right? Let's look at the head. And let's give me 10 of them. Okay? So day n is not necessarily counting the number of days since baseline. It's counting the index of that row, right? Because if you look right here, this is May 10th.
Yeah.
That is 8 days after the second. Day n is saying 6. So it's not actually 6 days. It's saying this is the 6th record, which may not be what we want. We actually want the number of days since.
Exactly.
Yeah, so that is probably a good check. You can also, I mean, we could also spot check another one. So let's say the unique, and I'll just say ID. Okay. So I want to say, give me the unique set of IDs where this stuff's happening. So let's do the same thing with this one. So let's, when we define X to be this thing, let's just change the ID variable up a little bit. And let's do this one more time. So, again, what's going on? They're both on, there's 2 on the 25th, right? And we can, daily, right? So, this is pretty interesting as well because we sorted the data. And the fact that we're doing everything on the day is okay. It's fine with what we're doing because the first row isn't the first row of actual data if you look here. Because this is at 8:30, this is at 9:30. Right? So we can sort on both of them, which we probably should. Now though, so that makes sense. So this should no longer, this isn't a day after. It's actually an hour.
Yeah.
It's technically this is an hour before.
And
the
actually
first
it should not be 2 the same day.
Yeah, so that's so for each person, right? That's a great example. So let's do this. So let's make a tab. So we don't need to do all this this stuff. So they used you remember the other day we used a group by. Yeah. So we're gonna do that, and we can say maybe that's not the best way to do. What I want to do is I want to table day n per person, right? And I want to see if any of those have account. So let's say X, right? This is the same table X day n. Sorry, day n2, right? So if any of those, right? So this is a table of the days from baseline, from the first daily measurement, actually. If so, this is just a quick tabulation, and all those should be 1, though at least from what you're saying. So we can identify those taken on the same day by saying any of this table greater than 1, true. So what we can do is we can summarize that by person, for example. So I think so multi-day, let's call that. And we can say is it I think it's just mutate. And then so again, you have to bear with me. I have not used this super much. Let's see, table day n2 is greater than 1, and we can just do an any around that. If I spelled things right. Variables not shown. Oh, we don't want it. See, we don't want that guy. We don't want that. We want transmutate, right? Transmute. Because I don't need all that other stuff. So say multi-day, and then we want to grab what ID? say that. That doesn't do what we wanted. Right, that actually doesn't. I think what we want to use is probably summarize. Yeah. Oh, we didn't group it by anything. Group by nothing. Cannot modify grouping variable. Well, I don't want to. Just want to get rid of it. Okay, still not what we want. Right, so we should, I think summarize should work. There we go. Yay. And then we can say multi-day, multi-day. So these are the IDs that have multiple, well, these are it's a subset. Right, so it'll show you the first 10. And we can sum this guy up to tell you how many IDs have multiple days. So 144. And then just say length, unique, multi-day ID, for example. That'll tell you the number. There are totally better ways to do that. For example, count and tally and n and all these other things that, again, that makes perfect sense to me. It's probably not intuitive off the bat, so I don't use a lot of those other ones. They are probably a lot better, honestly. So let's see. What is n daily? Unused argument. Okay, thanks. Oh, you have to use it like in a function. Yeah. But like if you wanted to know, if you wanted to create a data set like that counted the number of rows, so that person has 18 observations, and let's go back to that, right? So for example, now we can look at the data, so daily, so let's just do the head of, and let's select or filter. And I think we should wrap up probably in the next 2 to 3 minutes. Whoops. Daily ID is this, right? So let's see what's going on. Again, there were 2 observations taken on the same day, the 19th. And they were exactly the same time. This looks like a duplicate record, except that it has different pieces of information in it. So this is a little bit funky. Yeah. So, but this is hopefully shows you how kind of that you can check stuff.
No, that's very good, because especially when you are with a big data set, sometimes even that you check most of the data, sometimes.
Yeah. No, I agree. Okay.
Okay.
That sound good?
Sounds perfect.
It's a shame